So this is my second time recording this, so it should be a little bit more efficient since the video didn't save the first time. So we're just going to go ahead and get right into it. So we're going to be explaining some of the key differences into our weather program V2, and I'm going to just go ahead and get right in. So right here at the top are our sensor variable definitions. This was given to us in the code from the Google Drive, so I'm not going to talk about this too much. We're going to go down here and notice that I defined a new temperature and humidity timer delay, and that's to make it read a little bit faster than the weather API screen. And so we're going to go ahead and go down here, and we're going to get into here. This is just a placeholder for now, a default value, if you will, for the current temp and current humidity. So we're going to go into the setup and ignore, this is all old stuff. So we're going to look at these few things. As you can see, there's a couple of initialization code things happening here, and then a write data with proof. So we're going to go ahead and look into our I2C read write C++ file to kind of see exactly what's going on. This init I2C program file was given to us in the code on the Google Drive, so I'm not going to explain that too much. But essentially what I've done is I've copied this whole thing, including variables, and basically set a whole nother method just so that we could define a couple different sensors at the same time. And so what we have here is you can see on the readwrite.h file as well that we have those variables in that initialization method defined there. So we'll go back to our code, and now that we're done talking about the setup, we're going to talk about the loop code. And so what we'll do is we'll kind of just step through this logically so you can kind of see what's going on. So at the very, very beginning, the top of every single loop call, what we're going to be doing is getting the proximity data to see whether or not we're even going to be doing anything with the screen at all. So basically, if the proximity is less than 100, which basically means if something isn't too close to the device, then we're going to go ahead and turn the display on, get the ambient light sensor data from the read register 8 address 16 data method that was given to us, which you can see here. Oh, here it is. You'll see it's just taking that data, and that was given to us by the code online. And so what we're going to do is going to do a little bit of math there to figure out what to plug into m5axp.setLCD voltage. What this is doing is it's basically setting anywhere between 2500 and 2800 volts. Well, so 2.8 volts, or 2.5 volts, but that's done by a multiple of 100. So what we're doing here is 2500 is the lower bound, or very dim, if you will, and 2800 is the higher bound, or super not dim, or really bright, if you will. Sorry, I'm kind of losing my mind right now. But yeah, so we're basically setting the voltage to control the brightness, and then basically if the proximity is super close or greater than 100, we're going to be turning the display off, and just set the brightness to 0. So then we're going to go down here and we're going to talk about some of these buttons and how we had to change a few of those things. Button A, regardless of screen, will just flip imperial versus not imperial, which is basically going to control whether or not we're printing everything out in Celsius or Fahrenheit. And then on button B, we're going to be doing button B was pressed will toggle it to screen number 3, and screen number 3 is our temperature and humidity screen, and then you'll see here that it's redrawing screen 3. So if we go into this method here, it's kind of where a meat of a lot of the time that we poured into this went to. We're going to be declaring float temperature and humidity, and then calling our custom read temperature and humidity with pass by reference variables to the floats that we just declared. So we're going to go and step into that method here, and you'll see that we're basically saying we're going to read 6 bytes. We're going to retry 50 times, and it'll go through, it'll begin transmission on that wire to the temperature and humidity I2C address that we initialized earlier. It'll get bytes written here, and it'll do bytes written plus equals wire.write 0x E0. And what E0 is doing is that's basically telling the sensor that we're going to be doing, we're going to be targeting the low precision temperature and humidity. For some reason, high precision does not work very well, but low precision works great. So we opted for that method via the data sheet that we found online. And so what we'll do here is we're going to say return status equals wire.end transmission. The default value for this is true, hence why we're not actually passing anything in. It's basically the same thing as passing in true. And then we're going to do a little bit of a delay just so that we can give the sensor a second to start actually reading in values. And so what we're going to do here is we're going to do wire.request from that address, our number of bytes to read, which is 6. And then if the wire is available, we're going to get a uint8 array of 6 length, and then basically reading 6 times to that array to populate the array with the data that we need. And now all of this sort of math stuff was given to us by the data sheet in the pseudocode portion of the data sheet. So we basically just implemented that straight across and did a little bit of typecasting. And then we're basically taking those variables that were passed by reference and we're assigning those variables to the data that we just found, and then we'll return. So now stepping back out here, we're going to initialize the current temp and current humidity, the global variables, to those things that were just initialized, which is great. And then we'll step down here and we'll just do a bit of front end stuff to make it look pretty and print all the words out on the screen as you saw or will see in our demo video. Now it'll come down here and we'll just do some time format stuff. We're essentially just going to get the current time, AM, PM, make it look pretty, and then we're going to do a little read at or read at this time bit. So that is our redraw screen 3 method, and that's what's being called here. And then if we step into our m5.button_c was pressed, what that's going to do is that's basically going to toggle the zip code screen and the main screen depending on which screen you're on. Basically, if you're on screen 1, it'll flip to screen 2. If you're on screen 2, it'll flip to screen 1. And now we're not going to explain screen 2 and screen 1 because that's the zip code and the main weather screen. But what we will do is we'll explain screen 3, which is basically saying about once every second or however long we're defining in our temperature and humidity timer delay, we're going to redraw screen 3 or the temperature and humidity screen, and then we'll just reset the time. So yeah, those are all the updates that we've made. Here again is our I2C read-write C++ file. We had to change a few things to get it to work with the temperature and humidity sensor. And then here is our .h file as well that you'll see. We added a few method declarations and then a few more variable declarations in here as well. So I hope that made sense, and I hope you had fun listening to our code demo.